homework problem question.
I can hear you too. Okay, go ahead. Oops.
I'm on homework 3, part 2, question number 4.
3, part 2, question number 4. 1, 2, 3. Oh, 2 planets. Okay.
Yeah.
So let me make a copy. Where is there? All right, so 2 planets. Okay, I got it. And what is your question specifically? Do you have
So I just don't know how to do the first question because I don't think I can get rid of the radius.
What did you try?
So I tried to use the equations, the 4 pi squared divided by t squared equal to g plus g m divided by r to the third degree.
Well, first of all, I always advise to start from the beginning.
Mhm.
And the beginning is a situation when you have one central object with certain mass. At this point, you don't know it yet.
Mhm.
We'll figure it out. And there is a satellite orbiting, correct?
Mhm.
So here you got force of gravity that attracts it, and the acceleration points to the center. If you're not sure if your certain equation didn't work, you have to start from the beginning. The beginning says mv squared over r has to be equal to the magnitude of the force of gravity.
Okay.
Did you do that? Because you have to calculate mass.
Mhm.
That means you will have to use something with the mass.
Yeah.
And you also know that the period is related to speed and the radius. How? How would you relate the period of the motion, the speed, the radius?
Isn't periods equals to is that vt plus t or
This is something you really have to know. Or if you don't know, you have to pull up the equation sheet
Mhm.
and look through until you find something related to that. All right, we can go from another end. Speed. If an object travels at constant speed, a uniform circular motion,
Mhm.
how do we calculate speed? If we know
Mhm.
something, what do we need to know to calculate speed? This is what I want to ask. Yeah.
So the displacement, the displacement divided by time and
Well, displacement relates velocity and time.
okay.
This
So
is
then
speed,
the distance divided by time.
distance divided by time.
Mhm.
Exactly. And if you look at something that spins around, what could be a convenient distance?
So radius.
Well, the radius would be a convenient distance if it falls right on the planet. It doesn't fall on it, it spins around.
So
So it starts here and then it travels in a circle and comes back. And what's the distance traveled now?
oh, so okay. so it's gonna be pi plus
Well,
pi times r squared.
well, that would be the area.
Yeah.
You need the circumference.
Oh, diameters.
The length of the circle. How do we calculate the length of a circle?
The diameter times pi.
Pi times diameter, exactly. And the period is time required to make one whole revolution. This is another definition we need to remember. So this is how you can relate these variables and solve it for the period. The period will be equal to pi times diameter divided by speed, or you shouldn't be using different variables. You have to choose either r, radius, or diameter.
Mhm.
So I would get rid of the diameter. So what should I write instead of a diameter?
2 times r.
So these are your initial equations. And now you can start thinking, how can you use them? Well, you can cancel mass here. You can cancel radius here. 1. So you've got oops. You've got v squared equals the constant central mass divided by radius. On another hand, period is equal to 2 pi r divided by speed. So we have to do something about this
Mhm.
to get the mass.
Okay.
Now let's see.
So you replace the r with the second equation.
Probably that's exactly what we should do, because you got r in both. You got r here,
Yeah.
and you got one r here.
And we don't know r.
And the r, well, if you replace r with everything else,
Mhm.
that's it. Or you can just solve for r, because the period for the first planet is supposed to be equal to 2 pi r divided by speed number 1. And speed number 1 should be related to radius number 1. And you know both. You know the period, which is this number of years. Is a year a good unit?
No.
No. So what do you have to do about it?
We should change year to second.
You need to change it to seconds. Now, speed number 1, I don't know I use my numbers. But anyway, speed number 1 is given in kilometers per second. Is kilometers per second a good unit?
No, we could change it to meters per second.
No. So you see, this is exactly what now you should do.
Okay, got it.
And eventually, this step-by-step calculation will give you the mass. It should be a really, really large number, like in my example. And then you can repeat the same type of reasoning, because for the second planet, you can write exactly the same equations, and you know now the mass. So you could do the same type of reasoning. Again, you don't need the radius. You could, but you don't need it. So you can replace the radius with what? The radius equals period number 2 times speed number 2 divided by 2 pi. And you can use this expression here, and eventually solve it for the period number 2. but that will be seconds. So you will have to convert it back in years to enter it.
Got it. Thank you.
Okay. So you can finish this calculation. Do you have a question about another problem, maybe?
Let me see a second. I think I have another one in part 3. Yeah, question number 7 in part 3.
Okay, I need to open it. Part 3, question 7. Water is moving at given velocity. Okay, so I want to do this again. Water is moving at given velocity. And it has two parts. Which part do you want to begin with?
I think I just need to know how to do the first part so I can figure out the second part myself. Because I was using the equation that's
Yeah, the continuity.
the areas
So
the
you've got
areas plus
water. So the density is 1,000
Mhm.
kilograms per cubic meter, traveling, let's say, at, well, I use my numbers, 2 meters per second.
Mhm.
And the diameter here is 1.6 centimeters.
Yeah.
The flow rate in liters, that's what we call the volume flow rate. So first of all, we could use either a definition or an expression that we have derived.
So I can just simply use 0.8 centimeters square and times pi to get the areas, and then
Well, the
convert it.
area has to be converted into meters. So it's a diameter over 2 squared times speed. So you cannot use centimeters diameter, so it's 0.016 over 2. That's the radius squared times 2.5. 2.5 meters per second. That is already a good unit, but the diameter needs to be converted, divided by 100
Mhm.
meters. This will be the volume flow rate in meters, yes, meters cubed per second. What do you need to enter?
Liters per
Liters.
second.
So you still will have to make one more conversion. We did it a couple of times, I think. We calculated a liter in cubic meters or 1 cubic meter in liters. So you can remember that, or you can derive it, or you can look it up. Do you remember?
Is it 10 or is it 100?
It is 1,000.
Oh, 1,000 or never mind.
1 cubic meter fits 1,000 liters.
Got it.
1 meter, 1 meter, 1 meter. So this is 0.001 of a cubic meter. So this is your conversion factor, which you need to use to get from Cubic meter is 2 liters, so basically you need to get this number and divide by 1,000.
Got it.
Now, what do you do next? Next, you attaching a nozzle. Okay, so now you start from the same diameter, but you're now attaching a nozzle which is narrower. So if you had speed number one 2.5 meters per second, now it should change. Speed number two should be higher.
Mhm.
Oh, it is higher. Yeah, it is higher. So the nozzle should be narrower. Basically, you are calculating what
Well,
diameter.
so I already used the VEFR. I just used that number to convert back to the diameters.
Yeah, you could do that, but I wouldn't.
Oh, is there another way?
Well, there are always usually several ways. Of course, you are absolutely correct. This number, which you get from part A, is equal to this product area number two times speed number two. You can calculate the area, and then you can calculate the diameter and convert it into centimeters. But
Yeah.
what I would do, I would say from the beginning again that continuity equation tells this product must be equal to each other.
Mhm.
So that means pi diameter 1 over 2 squared times speed number 1 should be equal to pi diameter over 2 squared times speed number 2.
Mhm.
So I can cancel pi and pi, I can cancel 2 and 2, and I can, what I'm looking for, d2. So d1 over d2, no, I want d2, just d1 squared times 2.5 divided by 14, and the square root of that gives me d2 automatically.
That would be like easier.
In centimeters, you can use the diameter in centimeters, and your answer will be automatically in centimeters.
Wait, so you mean like I use? Oh, okay. So I don't have to change anything.
If you do it this way, you don't have to use any conversions. You get the result automatically in centimeters. Well, you get unit for diameter, the same unit you used for the first diameter. Whatever unit you choose for the first diameter will be automatically the unit for the second diameter.
Got it. Yeah, I
So
know how to do
basically
it.
it's
Right?
this. Basically it's d1 times square root of 2.5 over 14. This is your coefficient. Well, my coefficient. Yours will be different.
Got it. Thank you.
Of course.
I think that's all the questions I have.
All right. Perfect timing.
Well,
Thank
have
you.
a nice day, Professor.
You too. You too. Bye bye.
Bye.
And we are done. Are we? Yes. Save. We are done with my office hours today.